In the last lecture, we started our discussion on a very unusual phenomena on Earth's history called the snowball Earth. The evidence, we discussed the evidence that there was a time around 600 million years ago when Earth was probably covered completely with ice. Okay? If it is completely covered with ice, it is called hard snowball, which many people find it hard to believe, because if Earth was completely covered with ice, they believe photosynthetic life it depends on photosynthesis, cannot survive. Okay? So, some people believe that there was a small region near the equator where it was not covered with ice. Okay? Now, we will not worry about whether it is hard or soft, but we would argue that 90 to 95% of the Earth was covered with ice. Okay? This is a very unusual phenomena. It has not occurred in the last couple hundred million years. It occurred only a long time back. Okay? And the evidence I showed in the last class of glacial deposits, calcium carbonate occurring on top of that due to greenhouse effect, then Barnard Iron formation due to the fact that ocean was exposed to atmosphere or completely not exposed due to ice and snow. Okay? And the carbon-13 isotope decline, which hinted that photosynthesis had almost stopped. So, here is Hoffman, I think in Namibia, where he is showing this layer between two calcium carbonate rock layers, in between a layer of I would say debris, glacial debris, containing these drop stones. These drop stones are stones which were dropped into the ocean by an ice sheet. This is the ocean, you can call it debris in the ocean, which was later on solidified. So, these are rocks which are not similar to these rocks. Okay? They are coming from far away on the ice sheet, they are being brought all the way and dropped in the ocean. This is a real evidence of a large ice sheet moving into the ocean and dropping these unusual stones called drop stones. Now, here is evidence from California, Death Valley, where you won't think of evidence of snowball. So, this color here shows soil which was completely what you might call ground to very fine resolution, which is called diamicetite, and on top of that you have calcium carbonate. Okay? So, this is where glaciers existed, and little later on top of the glacier is calcium carbonate deposit, indicating very strong photosynthesis and greenhouse effect. Okay? Again, another evidence from Hoffman's work of a rock deposited on the bottom of the ocean. This is the ocean soil in the ocean, in between a rock from completely some other place. Okay? This is on Namibia. So, what I want to realize is that evidence is there from all over the world, not just a few places. Now, this is a cartoon showing how glaciers bring rocks and drop them into the ocean. This is the ocean. At the bottom of the ocean you have silt and clay, and ice brings with it rocks and debris, which ultimately drops into the ocean, and these drop stones are from very far away inland. Okay? And they do not belong to a local geology. That is how you recognize it as a foreign material. Okay? Now, here is the evidence over the last period between 500 and 800 million years of two periods of almost completely ice covered Earth, and along with the carbon-13 isotope data showing that just before Earth was completely ice covered, photosynthesis had stopped gradually. Gradually photosynthesis came down, and in this time there was no photosynthesis, and then after the ice had melted, when the carbon dioxide built up, then photosynthesis again started. Okay. So, this is a very, very powerful evidence of photosynthesis stopping due to ice sheet growing all over the earth, and in remaining the carbon isotope value is remaining very low and negative for about 10-20 million years, and then recovering once the ice sheet is gone, started increasing when there was a very warm condition where photosynthesis occurred and the carbon isotope value reached a positive value. So, this is the evidence which ultimately convinced many people that Earth was once almost completely covered with ice. So, this whatever I mentioned to you is put in this slide so that you can read it carefully and understand how the carbon 13 isotope evidence along with evidence of glaciers and drop stones convinced many people that Earth was almost completely covered with ice. Now, why did this happen? Now, some people believe that this could only happen if the tilt of the Earth axis suddenly changed from 23.5 to 45 or 50 degrees. Okay. So, this is one hypothesis which is not accepted by everyone. Okay. So, the argument is at the present level of tilt of 23.5, polar regions are covered with glaciers, but if the tilt becomes very large, then the equator region will also be covered with glaciers. Now, this is a very extreme hypothesis. So, because you have to find evidence of some asteroid colliding with Earth, sufficiently big asteroid, which collides so that the tilt is changed. Now, I do not think there is sufficient evidence to prove that, but this hypothesis some people still believe in. So, the idea is that from 23.5 suddenly shifted to around 50 degrees. Okay. But as it is only a hypothesis and not enough evidence is accumulated. Now, one paper has been published this year in which they looked at the impact of a large asteroid which changed the tilt by when the asteroid impact occurred, huge amount of dust and sulfur dioxide was released by volcanic eruption, and that cooled the earth sufficiently. Okay. Here you are, I don't know how much gigatons of sulfur dioxide was released, and how the solar transmission declined, and that led to the ice age. Okay. Now, in this paper they have done detailed calculations showing how much gigaton, if it occurs, Earth will be almost completely covered with ice. So, that is an hypothesis. Okay. But evidence is not that strong to support the hypothesis. Okay. So, he has given a table showing how the temperature will change and whether snowball will occur depending on the amount of CO2. If the CO2 is very large, okay, 4 times the pre-industrial, there will be no snowball. Okay. But if CO2 is small like 190 for example, yes, it can form. Or if CO2 is large and the incoming radiation is small, then also it can occur. So, there is a combination of incoming radiation and carbon dioxide along with this impact which can cause snowball. But this is a very unusual hypothesis, but not yet accepted. Now, if you want to understand why snowball did not occur before 600 million or after 600 million, you need to know what are the conditions. The first condition for Earth to be completely ice covered is equatorial distributed continents. If the continents are near the equator, you know that land has higher albedo than ocean. Okay? So, and most of the sunlight is falling in the tropics. So, if tropics is mostly covered with land, then Earth's albedo will be much higher, and so the global mean temperature much lower, and the formation of glaciers and ice sheets is more probable. Okay? So, if most of the land is near the Earth, then the atmosphere will also be drier. Okay? And there will be less circulation which can transport heat to the polar region. Polar region will start become ice covered, although it will take time because ocean has a certain inertia in it. So, the requirement is you should have land around the equator, which is not true now. Okay? So, the Marinovan and Strutian ice ages appeared because of the following three reasons. Okay? One, the carbon dioxide was not very high. If it is very high, it will not form. The incoming radiation was lower than today. It was 94% of today's value, because as all of you know, the solar radiation was about 70% of the present value when the Earth was formed 4.5 billion years ago, and then the nuclear reaction going on in the sun slowly increased the solar output to the present value. Okay? It is almost linear, and this data is from astronomy. Astronomers looked at millions of stars which are like sun, and looked at their output depending on the age of the star, and they are able to predict that after the formation of the star, the radiation will go on increasing until the end of the life of the star. So, based on that, we can say that 600 million years ago, incoming radiation was 94% of the present value. And of course, there has to be a supercontinent around the tropics. So, these three were satisfied only in this period between 600 million and 750 million years ago. So, the argument was that if the Earth was completely frozen, then the carbon cycle won't work. Okay? So, how did the carbon build up again? So, for this we depend on plate tectonics, that even when Earth is completely ice covered, plate tectonics will continue to operate. Because plate tectonics depends on the heat at the center of the Earth, which is obtained from radioactivity, not sunlight. Okay? So, Earth's internal motion, the molten lava inside the Earth which is moving due to radioactive decay. Okay? So, plate tectonics continued, and so volcanism will continue. Okay? And those volcanoes will ultimately release CO2 through the ice layer, because as all of you know, volcanic eruptions are violent. Okay? When they occur, they will break open the ice layer and release CO2 into the atmosphere. Okay? So, the argument was that the snowball Earth cannot be there forever, because the volcanoes will go on erupting occasionally, and CO2 will be released in the atmosphere, and this CO2 is built up because there is no way for CO2 now to become calcium carbonate, because the carbon cycle cannot operate without photosynthesis. Okay? So, condition to get snowball Earth is as follows: reduced solar radiation, that we know, around 6% lower than present. Reduced CO2, some people have debated that, how much is, because we do not have actual measurement of CO2 600 million years ago, we have to guess. Okay? And low altitude continents. So, with these three, one can show that ice can cover the almost entire Earth. So, here is an approximate estimate of the carbon dioxide on Earth from its origin 4.5 billion years ago to the present. Okay. In the beginning, all of you know that Earth's atmosphere contains mostly CO2. How much we are not so sure. There is a whole range of values here. But as the photosynthesis started occurring, CO2 began to decline until we have values which are quite low today, 400 parts per million. Okay. So, this is based on a model. So, there could be of casting which I mentioned. So, there is a large error bar here. We don't measure the actual values. It is only a guesswork based on our understanding of how planets evolve. Okay, now this is a very important slide which will illustrate why snowball occurred in a certain period. For snowball to occur, solar radiation should be low, okay, not as high as present, but lower value. And in addition, CO2 should not be high. So, CO2 was high in the beginning, but solar radiation was low. Okay. So, at that time greenhouse effect dominated. So, snowball is probably slower. As CO2 started declining due to photosynthesis and solar radiation started increasing due to the nuclear reaction becoming more powerful in the sun, there came a time around 6 million years ago when the combination of low solar radiation and low CO2 was sufficient to initiate a snowball Earth. Okay. So, in this cartoon they have mentioned 4, but out of them we have good evidence only in these 2 cases. Other 2 there is evidence, but not very solid evidence. So, here is the configuration of the continents 635 million years ago and 720 million years ago as inferred by geologists. Okay. You can see that at this time most of the continent was between 30 north and 30 south, okay, most of them. And you can see India was at the equator 631 years ago, and 720 million years ago India was still near the equator. Okay. So, this is geological evidence from rocks and so on. It is called paleogeography. Okay. And the continent Rodinia supercontinent broke up. So, the most accepted model for the initiation of the snowball Earth depends very sensitively on the level of greenhouse gases like carbon dioxide, the presence of continents around the equator, and the level of carbon dioxide. All the 3 have to come together. Okay. So, it cannot happen very often. If CO2 becomes too high, the snow will melt away. If the continents start moving, go outside the equator, it is gone. And if the radiation of the sun is too high, also it is not good. So, it requires a very special combination. Now, other important thing is weathering. You must remember, weathering is a chemical reaction of carbon dioxide with calcium silicate, for example. So, as all of you know from your understanding of the Arrhenius equation in chemistry, that chemical reactions are very strong at high temperature. So, they mostly will form in the tropics, where temperature is above 0. Okay. When the temperature is low, chemical reactions are not very strong. So, you can see these orange and red portions are the places where weathering occurred prominently. Okay. Both some about little less 18 billion years ago. So, weathering also an important factor in understanding the carbon dioxide level in the atmosphere. So, equatorially distributed continents result in colder Earth. Tropics have higher weathering that causes CO2 to drop. So, we need a low CO2 and we need continents around the equator, and the albedo, as it starts increasing as the ice forms, we can move towards snowball Earth. Okay. Here is a cartoon showing the calcium silicate reaction with carbon dioxide producing calcium carbonate. So, this is a long term carbon cycle occurring over a billion-year time scale, okay, which we are not aware of till recently. Okay. More land in the tropics will lead to more weathering, okay, more rain and higher reaction rate due to high temperature. Rain is required to dissolve carbon dioxide to form carbonic acid. That is a requirement. So, this is the carbonate silicate cycle. Rainfall enables carbon dioxide to be dissolved. It weathers the silicate rock, brings in calcium carbonate, okay, and also controls the carbon dioxide in the atmosphere. Okay. So, it is a very delicate cycle. Temperature is high, weathering is high, carbon dioxide is removed. When CO2 is removed, temperature goes down, weathering becomes slower, carbon dioxide builds up. So, it is a very interesting cycle mediated by weathering and albedo and greenhouse effect. So, albedo plays a role, greenhouse effect plays a role, and weathering plays a role. There is another cartoon from Science article, shows how temperature dependent silicate weathering acts as the geological thermostat. So, before human beings came, Earth was able to maintain a fairly constant temperature for long periods because of the carbon cycle. Okay. Carbon cycle operated to maintain CO2 to be reasonably stable. This is another picture showing the same phenomena. Now, when the snowball Earth proposal was postulated by Kirschving and Hoffman, a lot of people who are doing climate modeling over the last 40 years decided to see whether this can be demonstrated in a climate model. We already seen in a simple energy balance model it can occur, but that is a very simple model, one can have doubts about it. So, unless they do it in a complex climate model with both ocean, atmosphere and land, one will not believe it. So, some people had simple general cycle model with mixed layer ocean, and they were able to make it freeze at the equator. A more sophisticated model with full dynamic ocean failed to form. Okay. So, then there was doubt, and level of CO2 necessary to melt the snowball after it is formed was very high. Okay. So, that also caused some question mark. Okay. But those have been resolved in the last 20 years with very good modeling. Okay. So, this ECAM5 model along with the MPI ocean model is a coupled ocean, atmosphere, land general cycle model. Showed a snowball when radiation was 1285 watts per meter squared, lower than the present, and when carbon dioxide decreased to around 500 ppm. So, it is possible to have snowball in today's climate model for a certain combination of solar radiation and carbon dioxide. Now, this I have shown earlier in this course, but I will recall that again. If you take this model which I have discussed just now, it initiates very known snowball Earth when you decrease solar constant to the present value to 94%, which was the value at that time then, and you calculate the sea ice area in the model as you decrease this CO2 to 278 ppm, then within about 500 years it is completely sea ice covered. But if the CO2 was as high as 1668 ppm, it doesn't form. So, snowball can occur only when CO2 is sufficiently low. Okay. So, you can see that in these two cases it did not form. In the case of the blue also it did not form, that is blue is 556. So, it required it to be reduced to 500 ppm, then it started forming. So, they are arguing that CO2 amount should be below 500 ppm. If it is 286, 278 it forms very quickly even at 100% solar constant, but here it is 94% solar constant. Okay. So, that shows that there is some combination of lower solar constant and lower CO2 which gives you ice covered earth. Okay. And here is more data showing combination of, this is total solar irradiance, 95%, 96%, so on. You can see that only for certain combinations like 95% solar value and the present CO2 concentration, or 95.5% also it begins to form little later, it takes longer time. Okay. But most of the cases the sea ice does not go beyond certain area. Okay. Now, here is the paper by Yang et al. How the snowball earth is simulated in the model for fixed concentration of CO2 with varying incoming radiation, and for 94% solar constant, which is correct for 600 million years ago, and varying values of CO2. Here you see clearly the CO2 has to be quite low, around 70 ppm or so, for snowball to form. If it is 140 ppm, it does not form. Okay. So, that is a thing which we do not know, because nobody knows what are the exact amount of CO2 600 million years ago, we have no data. Okay. And it shows two kinds of solutions. One kind where snow is there at the equator, and the other kind where the temperature of the equator crosses 10 degrees, there is no snow. This is soft snowball, this is hard snowball, both are occurring. Okay. And so, if you make it 50 ppm CO2, then most of the equatorial region is snow covered, but still in summer, June, July, August, there is some warm conditions. But this is fine. Life will survive if for a short time, few months a year, the earth is covered with snow at the equator, life will manage. As you know, life is very, very hard on earth. It can survive very, very adverse situation. So, if part of the year is it is snowball earth, other part is it is slush ball earth, life can go on. Now, here is a simulation of the coverage of sea ice in two different versions of the model, CGSM 3 and 4. So, there is small difference in the way the model is there. So, there is a slight difference in the way the sea ice evolves, but ultimately in both cases the global ice cover is close to the maximum value. And I wanted to notice that in this simulation, the ocean area is of course larger in the southern hemisphere. So, we get the blue line, and ocean area is less in the northern hemisphere. So, there is a difference in the curve, otherwise everything is similar. So, with this model, people have argued what should be the albedo of sea ice, that is whose thickness is about 1 meter. So, the range of values is 0.4 to 0.5 and 0.6 to 0.65 in the two versions of the model, and the observed variation is close to what CCM3 has. Okay? And in the case of snow with a melt pond, the values are snow only on top of the glacier. You can see the numbers are more realistic in CCSM4. Okay? So, there is still some doubt about the exact value of the snow albedo which will trigger the snowball earth. Okay? So, we can understand all this based on energy balance model which we discussed a long time ago, which is that if the incoming radiation is quite low, below 1 here, and the CO2 is sufficiently low, like 0.02 bar, which is higher than today, then you will get almost ice free earth. But if you go a little lower, then little lower here, then you will get ice covered earth. Okay? So, we need the correct combination of incoming solar radiation and CO2 in the atmosphere for you to have this state. Okay? So, this is what comes out of both the energy balance model and the GCMs. And the work of Hoffman, which is well known paper in science, he gives you a more complicated picture showing that stable condition. The black line is stable, dotted line is unstable, and he is showing there is an ice free branch and there is an ice covered branch which is stable depending on the amount of CO2 and the amount of incoming radiation. So, with these things we know that under certain condition snowball earth could have existed 600 million years ago, and I will continue the discussion in the next lecture to give you some more evidence to show that snowball earth did indeed occur. And so, with that we will close our discussion in the next lecture on the paleoclimate of the earth. So, all these were given to convince you that the earth climate went through various phases: ice free earth, ice covered earth, and in between. And so, one has to be careful about what can happen in the future. Thank you.